Yes, welcome to DC Economics. So I'm going to take you on the first linear differential equation. So we are going to begin by understanding a differential equation. That is an equation with a function and one or more of its derivative. For example, y plus dy over dx is equal to 5x. So this is an example of a differential equation. But to our focus, we are going to stick to understanding the first order differential equation. So a first order differential equation is given by taking, for example, dy over dx. So, but when you have the second order derivative, like the second order derivative of dy over dx square or d over cubic root over dx cubic, this is actually not regarded as a first order differential equation. So a first order differential equation begins with only dy over dx and not the second derivative of d raised power of 2y over dx square or cubic. So under linear differential equation, a first order of the equation, the first order of differential equation is we normally refer to as a linear differential equation. So a first order differential equation is linear since when we take dy over dx plus px times y is equal to qx. So whereby the px actually represent out together px together with qx represent out these are what are known as the function of x, whereby px and qx are the function of x. So we have this kind of form of a first order differential equation is linear when dy over dx plus px times y is equal to qx. Now from this equation here, we are capable to apply the product rule since when we have the y which is equal to uv. Since we have the two function y is equal to 2uv, when we apply the product rule, dy over dx will be equals to u over derivative of dv over dx plus v du over dx. Now from this equation here, now we develop this kind of a first order differential equation as linear as we take out the probability as we take out the px y is equal to qx as you can observe. Now after understanding that, let's go quickly and let's go quickly and look at an example so as it can be easier for us to capture the concept. For example, solve dy over dx minus y over x is equal to 1. So the first procedure from this kind of differential equation, we need to actually to prove if this is linear. Now any linear differential equation is actually given with the functions of dy over dx is equal to px qx is equal to 1. So from this equation, we need to prove it if it is linear. So dy over dx plus pxy is equal to qx. So this kind of a guiding formula can prove us if this is a linear equation. So when we wrote down by plugging the values, we have the dy over dx negative y over x is equal to 1. So this proves out it is linear since the place of x is equal to 1 over x, that is negative, and the quantity of x is equal to 1, as you can observe. So the step number 1, we need to substitute y is equal to uv. Since we have the function px 1 over x and qx is equal to 1, so we take out u dv over dx plus v du over dx, we substitute uv. So we minus y is equal to uv to the equation. So we minus uv over x is equal to 1. Now from that procedure, we factor out, the step number 2, we factor out v to the equation. So we actually factor out the parts of the functions that we take out v, then we open bracket, then you open the bracket, then you write du over dx. So this will give out this factor. This, when you factor out, it will be dv over dx plus v. Then you factor out, then du over dx minus uv minus u over x, which is equal to 1. So after taking that, let's go to another step. So step number 3, we need to set out v which is equal to 0. So when we set out v is equal to 0, our equation will become, it will be du over dx minus u over x is equal to 0. So we take out du over dx, which is equal to 0. We solve out du over dx. We take out u over x in the left-hand side, in the right-hand side. So when it will be added, it will be du over dx is equal to u over x. So step number 4, let's look another step. Another step, we actually take out the value. We set out, we apply the separate variable so as we can set out the function. We use separate value to solve the values of, to find out the values of u. So this will give out du over dx is equal to u over x. So we integrate both sides. It will be, when we integrate, it will be in u is equal to in x plus constant c. So in u will be equals to in x plus c constant. So we actually divide by in both sides. It will be u, which is equal to, it will be equals to kx. So when you take out in x plus c, it will be in x. That will give you kx, as you can observe. Remember, our k value was dominated on the previous equation, if you remember. So let's go to another step. So that was step number 4. So this is step number 5. So we substitute u is equal to kx. We substitute it in the step number 2. So remember, our step number 2 was du over dx. It will be it was u dv over dx plus v bracket open bracket du over dx minus u over x is equal to 1. So let you take the value of u, that is kx. So this will be equals to our u, which is equal to kx. And remember, the kx dv over dx is equal to 1. So we take out, we cross multiplication both sides to obtain out the actual value of v. So we solve v. That is another step. So how can we solve v? So this will give we apply what is known as a separate variable to solve the value of v. So we apply the separate variable. This will be equals to k times dv over dx is equal to 1. Let u divide by 1 both sides and cross multiplication. So when we take out kx times dv, it will be equal to ks dv, which is equal to dx, since 1 and 1 will cancel. So we divide by x both sides, we will obtain out k dv is equal to dx over x. So we integrate both sides so as we can obtain the value of v. So we remain out with any x, this will give out a slab over here. So kv is equal to any x, then plus c, which is constant. So we take out plus any c, since c, when we integrate, it will be any c, and when we integrate dx, it will be any x. So kv will be equals to, we plus any x plus c, it will give you any cx. So we divide by k both sides to obtain the value of v. So the values of v will be equals to any x cx over k. So step number 7, we need to substitute y, which is equal to uv. We substitute it to what is known to, we substitute it to find the solution of the original equation. So let's write the equation that we had, that is y over uv. Remember that we apply that function to solve out by product rule in the previous steps. So from y, from u, which is equal to kx, and v is equal to 1 over k. So and y is equal to uv. So let you plug in the value of u, that is kx, times the value of v, that is 1 over k in x. Remember, 1 over k is having in x. So we take out kx times 1 over k in x. So remain out, when you take out kx over x, it will give you, we divide 1 by 1 both sides, it will remain out with kx in x, as you can observe. Remember, we had in x over there. So let me write it appropriately. We had v, which is equal to 1 over k in x cx. So when you take out y is equal to uv, it will be equals to, we plug in the value of u, that is kx, times the value of v, that is 1 over k in x. So let you cross multiplication over there. When you take out k times 1 over k in x, then you take out over 1, 1 and 1 will cancel, k and k will cancel. So to remain out, y is equal to x in x cx, as you can observe. So from this function, from what equation we have obtained, we actually, this is the way we solve out the first order differential equation. So the y is equal to x any x cx is a solution to the value of the constant function to the original equation that we had, that is dy over dx minus y over x is equal to 1. So I beg you to go slowly pass throughout the starting point of the video up to the end, so as you can mark all the points that you have take you for better understanding. Thank you. This is DC Economics. Don't forget to subscribe and watch on other videos. Bye bye.